Hello. Dear students, Jai Hind, very good morning. Welcome back to our e-learning revision program. As you all know, we are discussing examples regarding lens. Two examples we discuss, and before I start today's lecture, I have already kept the data written here already, because that is going to help you in solving any particular example. Focal length, again, just have a reminder before we start our revision lecture 5. For concave lens, focal length is always negative. For convex lens, focal length is always positive. V positive means the image is on the other side of the lens and it is real and inverted. V negative image is on the same side of the lens and it is virtual and erect. For convex lens, there are there are two possibilities for V. It can be positive, it can be negative. But for concave lens, there is only one possibility. That means that you will get V always negative. Okay. So these are some of the important concept which you need to keep in mind. And today, dear student, you are attending lecture number 5 of revision, where we are going to continue our discussion regarding various numericals of lens. Okay. From the PDF, as you know, we have solved example 16 and 17. Now you just check example number 18. Okay. Just read it first. What is given in example 18? Read it. It is actually, I can't consider it as an example, but just to make your basics clear regarding the ray diagram. What is given? C. In sum number 18, an object 5 centimeter in length is held 25 centimeter away from converging lens of focal length 10 centimeter. Draw a ray diagram, find position, size and the nature of the image formed. Okay. Now, dear student, before we discuss about this, what is mentioned, you please note down. Height of the object has been given, that is 5 centimeter. It is 25 centimeter away. So U has been mentioned, which always remains negative. Okay. U equal to minus 25 centimeter. It is a converging lens, means you know converging lens means convex lens of focal length 10 centimeter. Obviously, when you are dealing with the convex lens, focal length is always taken to be positive. It is 10 centimeter. Let me correct it, okay? Now, dear student, what they have asked, they have actually asked you to draw ray diagram and guess position, nature, and size of the image. What my target is that because we are dealing with the numericals, my target is that rather than no doubt, after we will solve this example completely, we will also draw the ray diagram to understand it, no doubt. But first, let us, rather than going for the ray diagram, let us move as per the solution of numerical. Okay, we are looking for m, we are looking for h dash, we are looking for, okay, understood. I want to solve it first for you as a important numerical. Let us do that first. Let us solve it as a numerical, okay. So dear student, what will you write? As per, okay, as per, this is compulsory for you to write in solving any example. Let us mention 1 upon v minus 1 upon u equals to 1 upon f. Ultimately, before solving the example, you might be clear, dear student, because it is convex lens, v has to come negative, m has to come positive. It has to be very, very extremely clear in your mind. Okay. Substitute the values. 1 upon v minus u has been minus 25, 1 upon 10. Okay. Let us transfer. This is, dear student, minus minus plus. Transfer it in this side. Minus 1 upon 25. Okay. Now it's a question of taking LCM. Okay. 1 upon V minus 1 upon U. We have already mentioned all the values, and it has been mentioned that it is a converging lens. Understand, focal length 10 centimeter and this is 25 centimeter away. Understand, converging lens, it has been mentioned already. Let us find it out. Here I just like to mention the word converging. That means, dear student, you know convex lens. Okay. So what about your conclusive analysis? Because it is convex lens, we may come positive or we may come negative. Understood? Let us do it. It's a simple question of taking LCM, cross 1 upon V 16 upon 25 into 10. Cancellation 5 3 ja, 5 5 ja. Okay. So 1 upon V equals to 3 upon 50. Okay. Just reciprocalize it. 50 upon 3. If you just carry out the cancellation, okay. So 3 is 16 ja 48, 2 left, okay. So 3 6 ja 18, 2 left. Okay, this is going to continue 16.66 centimeter. We turn out positive. That simply means V positive means image is real and inverted on the other side of the lens. Is it clear in your mind? And because V is positive, that is 16.66, that means M necessarily has to turn negative. Okay, let us continue here. M equal to V upon U. V, that is 16.66. This is minus. So obviously it is going to be minus. Understand, just multiply 4 here. So you will get 100, and this is just 4 6 ja 24, 2 26, 2, okay, 26, 2 4 1 ja 4 plus 2 66.64. You can just place minus 0.6664. That's the value of magnification. To be more precise, you can write this way. It is all okay. Minus 66. That's, you got already the value of magnification. Somewhat you can sum up minus 6.7. That is also going to work. Okay, but this is sufficient because when the division is not terminating, you can take arbitrary values. Okay, M equal to H dash upon H minus 0.66 H dash upon 5. Just cross multiply. This is going to be 5 6 ja 30 or 33. Okay, 3.30. Understand? You got the height of the image already. So dear student, just you verify. Okay. Okay, so you got the answer already. So, which are the important fact? V, then you got the magnification, then you got H dash minus 3.30. I am not just writing the statements of the answer here, but I am just speaking them out. First, what you would like to write? V plus 16.66 centimeter. That means your first answer, image is obtained at a distance of 16.66 centimeter on the other side of the lens. Next statement, V positive means image is real, inverted and of size 3.30 centimeter. You marked one thing, height of the image was 5, height of the image 3.30. That means what happened? The size of the image has reduced from the size of the object. This we verified from the example. Actually, in textbook, they have mentioned to draw the ray diagram, and that also because we got the image height 3.30 centimeter. Let us also verify it with the help of lens diagram. Okay, first you note down this before I go for the lens diagram as per the given basic facts. Okay, first you will like to write the statement what I spoke. Image is obtained at a distance of 16.66 centimeter on the other side. Whenever we are speaking other side, that means object left side, image right side. It is virtual and erect of the size 3.30 centimeter, and then we will verify it with the help of lens diagram also. Understand? Here actually you got which type of image. If I just want to mention real, inverted and smaller, you understood? Real, inverted and smaller. Let us verify as per the lens diagram also, because they have mentioned in textbook to draw the ray diagram for this, for verifying this particular fact. Okay, suppose, dear student, let us go as per ray diagram. Suppose I draw lens diagram. Okay, as you know, the center line for the lens. Okay, convex lens. Okay, optical center here. What is the focal length has been given, dear student? 10 centimeters. So obviously you know you do not have to go exactly as per given measurement, but if I write F1 and F2, obviously this is already 10 centimeter, that we are just supposing that it is 10 centimeter. Obviously, if I just mention here center of curvature on both sides, obviously it is going to be 20 centimeter. This is 10, this is 10, 10 plus 10, this is 20 centimeter. Where you are keeping the object? 25 centimeter. That means away from center of curvature, and you are extremely sure about the ray diagram if you have practiced them thoroughly, that whenever the object is kept away from center of curvature, where you get the image, so you must be knowing. Understand? First, this is what you have already practiced, which is going to pass through the focus. Okay, and another one directly passing through optical center to intersect here, and this is the image, dear student, A dash B dash. So you can verify the fact that image is real, inverted and smaller. We got value of the V 16.66, somewhere between 16 and 20. So this is the fact is also getting thoroughly verified with the help of the diagram also. Understand? So actually in this particular example, what they want as per the NCRT book and the exemplar is that student has to first assess out the given data, and they have to at least be sure that the object is kept away from center of curvature. And you know, dear student, as you know the diagram, when object is kept away from center of curvature, where you will always get the image, so always the image is real inverted smaller, and it is going to be between f and 2f, where you got the distance around 16.66 centimeter. Okay, so this is one numerical we have just now solved. That's numerical 18. The numerical 19 is of the same type, dear student. You can verify it by yourself also. Okay, it's not so difficult numerical. As I have discussed just now, you can verify it by yourself, not so difficult. Okay, so from PDF we have solved numerical 18, 19 can be a self study. Now let us see some more numericals from your PDF. Okay, so we are now targeting some of the examples, okay, from PDF itself, that is, just you verify the example which is given. What is that? See, what is given? Example number 20. Just you read and let me erase the data from here, okay? You just have a look at the sum PDF. In PDF, it has been given. What is given in that? See, the read this one, number 20 we are discussing. A concave lens has focal length 20 centimeter. Okay, and then what is mentioned here? Focal length 20 centimeter. At what distance should the object from the lens placed so that it forms the image at a distance of 10 centimeter from the lens? Now, dear student, example number 20, which we are targeting first. What has been mentioned there? Concave lens. The moment you come across and you just read out the type of the lens, it needs to struck in your mind. Understood? It is concave lens. Focal length is given f. Because it is concave lens, focal length is going to be negative 20 centimeter. At what distance the object should be placed to get an image at a distance of 10 centimeter? Okay, we we are looking for. Now again the concept clarity. Whenever it is a concave lens, V is always going to be negative. Okay, and where the image is obtained? At a distance of 10 centimeter. Okay, data which has been given are described, and now you will write as per lens formula. As per lens formula, 1 upon v minus 1 upon u equals to 1 upon f. Let us substitute 1 upon minus 10 minus 1 upon u, 1 upon minus 20. Let us transfer minus 1 upon 20 plus 1 upon 10. Okay, minus 1 upon u. Simple cross upon 20 into 10. Okay, minus 1 upon u, 10 upon 20 into 10. One cancellation. 1 upon 20, just reciprocalize, minus 20 centimeters. So, where you will keep the object at a distance of 20 centimeter in front of the lens. Okay, the final statement you will write. Therefore, object should be placed. Object should be placed at a distance of 20 centimeter in front of lens. Okay, this is an example, dear student, from your PDF. Okay, there are few examples. 20 we have solved already, right? All examples are not looking so difficult. Okay, you just verify the number 20. 21, I think you can solve it by yourself. 21, okay. 22, that also you can solve yourself, not so difficult. Let us solve one more example for you, okay. 22, let us solve. But I think it's not so difficult for you. 22, you can do it by yourself, okay. Then let us go for, as from your PDF, number 23, let us go, okay. 23, let us do, dear student. You first got the idea regarding this, okay. Now let us move for example number 23, okay. Number 23. First, before I start discussing that particular example, first you just read it yourself, and then we will target this particular example. First you just have a look at the sum. What is given in the data? Power of convex lens. Obviously, concave lens has got negative power and convex lens has got positive power. That concept must be very, very clear in your mind. Power of convex lens is plus 4.0 d dioptry. You know that. At what distance should the object from the lens be placed to obtain its real and inverted image of the same size on the screen? Okay, first you need to understand the basics of this, dear student. Understand, very important for you to first understand the basic. See, 23. It has been mentioned in the example the power of the lens is given, that is given for dioptry, that you all know. Now you have to check, dear student, where you should place the object so that you get real inverted image of the same size. See, dear student, first power has been given plus 4. Okay. Now, dear student, power has direct relation with f, that you all know very well. Power is the reciprocal of focal length, simply means that focal length is also the reciprocal of the power. So you can write this way: F equals to 1 upon P, okay, 1 upon 4. Okay, so 1 upon 4 you got. But as you all know, whenever you find focal length from the power, it is always in meter. Okay, so we need to convert it into centimeter. So simply just multiply by 100, cancel it out. You got the focal length 25 centimeter. This is clear, no, dear student, in your mind? Whenever you want to find power, as you all know, if focal length is given, you will have to first convert it into meter. Then and then you are able to find the power. So here, because power has been given, so when you just took the formula F equal to 1 upon P, you are getting focal length in meter, which is to be converted into centimeter in perpex of the lens, as you know. F equal to 25 centimeter. Now, dear student, what is mentioned? Where should the object be placed to get real inverted image of the same size? Again, all diagram of the convex lens has to struck in your mind. Can you tell me where you will get the real inverted and uh, image of the same size? Whenever the object is kept at center of curvature. Obviously, you can guess, dear students, center of curvature means indirectly it is radius of curvature distance from the optical center. So, if you find this way, R equals to, as you know, 2F, 2 into 25. What you got? 50 centimeter. Just if I give you the rough idea, as you all know, here F and here C If you keep object here, then and then you get exactly at the center of curvature real inverted image of the same size. And how much away it is? Because focal length is 25, this is obviously 50 centimeter. You understood? So your final answer is object should be placed, okay, should be placed at a distance of at a distance of 50 centimeter. Okay. This way, dear student, you can consider it a simple numerical. You can consider it a numerical at the same time objective also. Understand? In case of objective also, they may be able to ask you such examples. Okay? Just have a look at the sum and try to gather the basic concept. Then and then you can solve such numerical. Okay? Right. The same numerical, why you need to practice? You just need to twist it. Understand like this, that we by just I twist by keeping the object in front of the convex lens, we are getting real inverted and image of the same size of the object. If radius of curvature is 50 centimeter, what is the power? From radius of curvature 50, you will get focal length, and then from focal length you can get the power very easily. Understood? So this number 23 for you. Okay. Now dear student, let us take one more, number 24. Okay, let us see that also. Actually, the concept now which I am discussing is this concept, dear student, doesn't need you to just verify how you got the formula, but it may happen that when you go, understand, and when you come across in future in 12th standard, when you will learn optics, at that time you will come to know how to calculate the power of combination of the lens. Understand? You just here it happened that you are just given a glimpse of this, but at that time when you go across in future in 12th standard, when you learn optics, you will understand really how can you get the power of combination of two lens. Here we are just having look at one of the example, number 24. What is mentioned there? You read it. Two thin lens, and dear student, concept which we are discussing now applies only for the thin lens, that you need to keep in your mind forever. Only thin lens. Understand? What is mentioned? See the number 24. Two thin lenses of power 3.5 diopter and minus 2.5 diopter are placed in contact. Find the power and focal length of lens combination. You read the sum first. Here, what is mentioned? Two thin lenses are mentioned and their power are also mentioned. What are the power of the two thin lenses? Plus 3.5D and minus 2.5D. Now, dear student, when it is a question of two lens anytime, the first power, suppose I say P1 plus 3.5 diopter. Okay. Second one, minus 2.5 diopter. Okay. Obviously, here the power has been mentioned positive, so it is definitely a convex lens. Here the power has been mentioned negative, definitely it is a concave lens. So you are for designing some particular optical instrument, you are going to make an assembly of one convex lens and concave lens to get desired power of the assembly. Okay, how will you find the resultant power by the assembly of the two lens? You can mention this way: P equals to, just to remember, you have to algebraically add both the power. Okay, 3.5 minus 2.5. Okay, this is going to be 1 diopter and it is positive. So dear student, you can guess that the power of the assembly of the two lens is plus 1. Plus means even though you combine one convex lens and one concave lens, the resultant power produced will be of convex lens. Understand? So you can write, therefore, power of combination is plus 1 diopter, and you will also at the same time write it also, it actually generates converging assembly. Why converging assembly? Because the power ultimately turns out to be positive. If we want to just find the focal length of this assembly, 1 upon p, 1 upon 1, it is going to be 1 meter. Okay, this way numerical can rest of the numerical which are mentioned here, you can solve it by yourself. Number 24, 25, 26, 27. Okay, but this is concept you have to keep in mind whenever you are asked that we are for the design and manufacturing and for supplying some proper converging or means a resulting converging or diverging assembly, you will be given sometime the combination of the lens. So whenever you are given the combination of the lens, how will you be able to find its power of the assembly? Just by algebraically adding powers of all the lenses. Understand? And just by you get the value of the power, that will give you an idea whether the assembly will be converging or diverging. Suppose if we would have got minus 1d, you will have written the word that it generates an diverging assembly. Okay, as per the requirement, such assembly of lenses are also today combined to create some necessary power in design of optical instrument. You understood this? Okay. So dear student, this is today lecture number 5 again for revising. Understand, as we started it in lecture 4, but lecture 4 and 5 both for simply the revision of all examples regarding lenses which you need to practice more and more will help you in 12th when you cover optics. Understand? But at the same time, it is important for you even for your NTSC phase 1. So prepare thoroughly, make your concept clear and always keep when you solve numerical regarding lens these basic points in your mind. You understood this, okay? Thank you very much.